Hey guys, my name is xOctoManx, and in this tutorial I want to show you how you can create circles with the shuriken particle system by using code, and of course how you can extend that circle to show a helix. Also, there are several possibilities you can do afterwards, and I'm going to show you everything you need to know to create a circle and or a helix. For a helix, I just need to change the frequency to maybe 3 or 5. I will go over into that stuff later on, and the z value to maybe 1. So, and what you can see in a second, there is our helix is going to grow up. I hope you can see that. And it's circling around itself. When you look from the down to the bottom and so on and so forth, then you can see there's our created helix. And yeah, that's what we are going to produce in this video tutorial. So be prepared for that. We are going to start off with an empty particle system. So just go over and create one. Right click in your hierarchy panel and say particle system. The basic particle system isn't just anything we need for this tutorial. You can later on go and change all the particles you want to create smoke and stuff. I don't know. However, let's go into that. What we want to do is at first we want to get rid of shape, so we only have a stream from the bottom to the top and nothing else. Also, I go over color over lifetime, double click that shape, and the first color in here, I want this color to be green just to see it better at the start, and the end color I want this to be red. You can double click that markers, or you can go over into that color palette panel and just go over and change that. Okay, once done, I don't need to go over and do anything else in here. The rest we are going to create and do is using code. Okay, so let's go over and create a new C# script. Call this one ps_circle, for example, or use whatever you like. Go into the particle system itself, close it for a second, and drag in the ps circle script we just created onto the particle system itself. Then don't forget to open this one up in MonoDevelop or Visual Studio if you're going to use this. And then we have a blank or almost blank one. What we need is 4 variables at the beginning. I'm going to go over add all that stuff later on, so I hope you can follow up every step. So at first what we want to say is we want to create a public variable of type int, and I call this one frequency. It's going to be equal to be 1. The frequency is the repeat rate of our circle. So when you're going into math and look what a sinus curve is going to be, then you know that one circle around is a 360-degree one. We do the math in just a second too. So if this is 1, if the frequency is 1, we have one full circle. And that's what we're after. If this would be smaller than that, like a 0.2, we wouldn't have a complete circle. So make sure you are using that one. Okay. The next one, by the way, you can later on go and increase the frequency, as I have shown you in the preview for the helix. So as you want a helix with 3 or 5 circle arounds or surroundings, basically, then you can change this one to 5 later on. Okay, so let's create the next the next variables. It's going to be again public. It's of type float. Make sure it is float. And I call this one resolution. And resolution can start at, I don't know, 20. Resolution is the amount of keys. The amount of keys on the created curve. So remember that one. So if you want to have a finer curve, then you want to increase the resolution. If you want to have a rough curve, then you decrease the resolution. So if you're later on increasing frequency, it's better to increase resolution too. Okay, So the next one is going to be another float variable, which is later on only between -1 and 1. And this is going to be the amplitude. I go over to the amplitude later on. The amplitude is the height of the maximum value of the curve. Whoa. That's funny today. So there's the min and the max height of the curve. We can later on go over, or you can later go over and play with the variables. And the last one, which basically we don't need, but I want to implement that just for showcase, and this is going to be the z value or z value. This value is basically a speed value, as the speed already is. So for speed. Also, it's going to be affecting the z curve or z curve. So what we want to do is we want to create our first, or basically foremost, the only function we just have, and this is going to be called void create circle. What else? We don't need update, so get rid of that one. We don't need all of that stuff in here. We just need start. And what we can do is we can already, when starting the game or your whatever you are going to create your game in this case, then you go over and want to start to create the circle in runtime. We don't change anything in runtime, we just create this once, so basically all the shapes which are needed, and then when the game starts it will already create all of that stuff. So if you want to have that later on, if you want to check mark this in the editors, you need to do editor scripting, and then you don't need to call start for this one, but you need to call the script from the editor. I don't go over that one because it's going to be too complex for now. Okay, so what we want to do is, at first we want to have our particle system, or access to the particle system directly where the script is on. So I say particle system. Well, there are so many parts in here, which is the first one, and I just name this one PS for particle system, of course. And what we want to do is we want to get the component of type particle system. Where is it? There it is. Oh, I go over and increase the size a bit so you can see this one better. I'm sorry for this. So yeah, for now you can see this 100% better, I believe. Okay, in the next line I want to create a new variable, just var, and I call this one val for velocity. We will change the velocity over lifetime by that curves we are just going to create. So the velocity, or this value, this variable val, I can also call this one velocity, but I don't want to have problems later on with naming conventions, which is, as I said, velocity over lifetime, like this. So now we catch velocity over lifetime from the particle system in that variable, so we have easy access to all axes or all curves directly in that velocity. Also, we want to make sure that velocity over lifetime is going to be enabled once we are starting the game, if we haven't. Also, I want to make sure that velocity.space is going to be equal to the particle simulation space. Where is it? There we go. Dot local. So this is going to happen in the local simulation space of the particle system itself. You can also go over and use world, but for now just leave it alone. World might later on be interesting if you're creating, I don't know, tornadoes or anything else. Okay, the next one, what we want to add is, or change, is the particle system dot speed. Where is it? Start speed. There we go. The start speed is going to be 0 for now. Again, the start speed is going to be basically doing the same as the z value. I will show you this stuff later on. But basically, so don't be confused. The that value and the start speed needs to be at 0 at first, so we see our work better. The next thing is our velocity.z, which is a z-axis. We want to set this one at first. So what I want to set for the vel.z is going to be a new particle system min-max curve, as you can see here. So what I can change in here is at first the maximum amount of the values, which is the scalar value, as you can see here. And what I also want is an animation curve. But since I don't have any curve, I just take a value, which is the z value we just created in here. So copy that one in if you're unsure, and make sure that you don't have any typos. Okay, so that is already set up. Now the calculation stuff begins. So, as I said, we are going to use math for this. And what we need is an x curve, which is a sinus wave, or a sine wave. And we want an y curve, which is a cosine wave. So, at first we create a new animation curve. Animation curve. Where is it? There we go. Animation curve, and we call this one curve x. And this is going to be equal to a new animation curve. And that's it for the line. So we create a new curve, basically. So what we can do is we now have access to that curve by just curve x, and we can plant in any information. So let's say we have a resolution of 20. We want to make sure that all those 20 points are created in a sinus shape or a sine wave shape on that curve. So we need to calculate all that points or keys in that curve. How we do that is we go over and use a simple for loop for this. So we start at 0 because 0 is our first point. And what we want to do is we want to say once or while I is going to be smaller than our resolution, which is the amount of points we will go over and create, we want to increment I. No, not if, I. So while we are looping through that for loop, oh, that's wrong. I forgot I. So int I is going to be equal to 0. I'm sorry for this. So int I is going to be equal to 0, while I is smaller than resolution, then we increment I. That's a basic for loop for this. Okay, so what we want to do is we want to create some new variables in here. At first a float variable, and I call this one new time. This is the time which is going to be spent on the values or on the, I'm gonna show you this one pretty quick. Velocity over lifetime. Let's say I change this one to curve. Basically you don't need to, yeah, that is just for showcase right now. So what we need to create is a variable on the time, which is in this case the x-axis of that coordinate system. This is going to be the y-axis, which will be the value of the key on the position of the time. Oh, and don't want to increase that one. So I go over and change everything back so you can see everything is working later on. So what we need to do is we need to create that time, and it is a value between 0 and 1. So we need to first set all the 20 points inside of that time, which needs to be between 0 and 1. So how can we calculate this? Well, basically we divide I by the resolution. And of course we need to make sure that we decrease resolution by 1. Also I need to change this one into 2 brackets. Otherwise we would have an overflow, or basically 1 point too much or too less. So make sure that you divide I. So at start, I divided by the resolution of 20, we would get 0. So the first point created, or the first time of the first point or key, is going to be 0. If I is 1 because it has been increased, then it would be 0.05. And so on and so forth. You can do the math in your head or just write it down, use the Excel table, or I don't know. Okay, so I hope you understand that. So we need that to have a full line, or a full, a full shape of points in time. So yeah. Let's go forward to the next one, which is the value itself. This is going to be a bit more math right now. I call this one my value. You can use any other term or any other name for this one. So let's start with the sine curve. Since we are on the x curve, we are going to create the sine wave right now. So what's a sine wave? Sine wave is basically a mathematic formula basically to show and calculate circles. So what we do is we type in mathf.sine, so we have that function already from Unity or basically in C#. And what we want to do is we want to say new time, which is the time based on the time we just have, and we want to multiply this one by 2 and by mathf.pi. So this is the math for an easy sine wave. So this value, I will go over that in just a second. This value will be automatically calculated by the time we just have wasted, and of course by the normal curve or the normal circle calculation. The next one is, I'm gonna leave a space in here just to see it a bit better. So we want to set curve x, and what we want to do is we want to add a key to curve x, and this key will basically represent those two values we just created. So the first one is going to be new time, and the second one is the value. As you also can see, the first one is the time value, the second one is a value which is something between -1 and 1, except we are using an amplitude, but we'll go over into this one later on. Okay, so in here I type in my value. So we create 20 points between 0 and 1 on our on our curve, and this is going to be automatically filled in all that infos into that curve at key stuff. After we are through the whole for loop in here, we want to set the velocity x, which is again the curve in velocity over lifetime, and we change or create a new particle system min-max curve, as we have done with velocity z over there already. So basically what we can do is we can copy over that stuff in here maybe, and in here we don't want we want to have that 10 value too, but in here we want to set curve x. So all that curve x values created in that animation curve we just have and stored all that informations in will be automatically set to that curve. Let's test this one out. I'm gonna save my script. I don't know why it's red in here. I just go over and build this once. Oh yeah, of course I forgot to end that point in here. Gonna go over that. Oh yes, I forgot to set val.earnable to be true, of course. So otherwise this wouldn't work. So val.enabled is going to be true in this case. So this is what the problem was basically. Okay. Now let's go over and test this one. Don't forget to save often, otherwise you might lose any informations or anything else. Okay, so what we're gonna do is I press play right now, and now you can see just the line, but you can see the particles are going up and down, up and down. And of course I'm gonna go and show you the velocity over lifetime. As you can see, it already activated itself, and as you can see, there we go. There is our sine wave. That's what we want on the x-axis. So what we also want to do is we want to stuff with the y-axis. So we go and create the cosine directly under that. What we need to do is we just go over, we are lazy. We copy all of that stuff, leave a space, and we change everything which has curve y or curve x, and change this one to curve y, which are those three. Those three needs to be curve y right now. And also, instead of using math.sin or sine, we go and use cos for cosine. In the last line, instead of changing velocity.x, we want to change it to velocity.y, since we are on the y curve. So make sure you change this one from x to y. Don't forget to save, and now let's get back and yes, let's see how our circle is going to look. There we go, a super smooth and pretty interesting, of course, nice circle. Also, you can see we have the cosine wave in here with our 20 resolution, and our sine wave, which is this one, also with a 20 resolution. When I would go over and change this one to maybe 5 points and create that shapes once again, you would see it is not as accurate because of the handles itself. So it's not really a good not really a good circle in this case. Okay, so change the resolution to at least 10 to make sure that we have some interesting and also almost accurate. Well, yeah, that looks pretty much accurate, but yeah. Make sure that you use enough resolution points to have enough points on the curve, and so you won't have any problems. As you can see, very accurate and pretty smooth with 20 resolution. So now let's go and add some more interesting features, which is the frequency and the amplitude for this port. So what's the frequency? Again, the frequency is the amount of full rotations we will have in our wave. So this number here and this number here in the cosine and in the sine wave are determining the full circle. So if this is going to be 2, that means 2 multiplied by mass after pi, or pi, is going to be a complete circle. If it is lower than that, like maybe 1, then it would just be a half circle. 0.5 times pi would only be a quarter of a circle. So I hope you understand that. If I now multiply this by 2, you would have a 4, which would means when I have a 4 in here, I would have 2 sine waves. So the first circle and the second circle. And so we need to multiply this by something to make our frequency work. If I want to have 5 cycles or circles, then I want to need to multiply the frequency of 5 by that number. So what we do is we just clamp this one in because we want to get this one calculated before. So we say frequency times 2 is going to be and that is going to be the part we need in here. Make sure that you copy this one over to the cosine too. So what we now have, if I have a frequency of 2, then I would have 2 circles or 2 cycles around that circle we just created. I hope that is understandable. So now let's test this one out. Oh, I need to change, of course, the cycles or the frequency in the script. Then we can see the sine waves will double. As you can see, it doubles in here. Now we have, in the same amount of time, we have the double amount of cosine and sine waves. And we have also a faster and a smaller circle. So when I choose, let me go and do that once again. When I choose a frequency of 1, our diameter or radius will be doubled, as you can see. So make sure you use this one properly. So if I go over and change this one to 3, it will again be smaller in its radius, and faster of course too, because the sine wave needs to be calculated 3 times in the lifetime of that particles. So lifetime is another important part later on, if you want to create the right shape basically. Also it will affect the speed a bit, but you have a lot of possibilities. Okay, enough for frequency. Now we go for the amplitude. The amplitude also affects the radius basically. So normally we have an amplitude of 1. So let me show you the amplitude once again. Gonna open this one up. As you can see, now I have that number of 10 as it is the maximum value. But if you would look into that one deeper, like selecting this key here, as you can see, the value is still 1. So this is just a scalar value. It's scaled up to 10 to have a bigger radius, in basically. So our key in here still has a value of 1 and is multiplied by that scalar value, which is 10. We just set this one to 10. You can set this to anything you want. I just want to make sure that you can see everything we are working on. Okay, so this is the amplitude. The amplitude is the maximum amount and the minimum amount, which is -1 in this case, in the down below, to make this wave work basically. As you can also see, the less the resolution is, the less the quality of the amplitude is, and so we have some small changes in there. So if you go over and have a resolution of, I don't know, maybe 100, you would have a lot of points, but this would be a very accurate, and as you can see, very accurate pretty much to the upper and down part. So you decide what's going on and what's the best. I can tell you 100 is pretty much the best you can use in here. Don't overdo it, but a resolution of 100 might be the most interesting one for you. Also later on, if we have a frequency of 10, you need all that points. Gonna go over, as you can see, a pretty accurate curve. Still for a 100-ish point curve, maybe a bit too less, not accurate enough. So you might want to go over later on and increase the resolution to maybe 500. I don't know, I never had tested this one, so let's go over and test this so you can see it. As you can see, we have now 500 points and these curves are pretty very, very accurate right now. So depending on the height of the frequency, you go over and create a more interesting resolution or a higher resolution. With a frequency of 1, you don't need to have a 500 resolution. So keep that in mind. Okay, back to amplitude. How can we add in amplitude? Basically, amplitude, or our value or our y value is mathematically seen just amplitude times the cosine, or times all of that stuff in here. So what we type in is amplitude, leave a space to amplitude times mass f dot cosine in this case, and so on and so forth. And the same happens for the mass f dot sine wave. So again in here, amplitude times mass f dot sine, and so on and so forth. So if I would go over and change the amplitude right now in our script in here to 0.5, you will see, well, not 5.1, 0.5, and I start right now, you can see it will only be half of the part or half of the strength of the curve. You can open this one up once again. As you can see, it starts here at 0.5 and it also will end at 0.5, and the minus part in here will be at minus or almost minus 0.5. There's no spot in the middle, but as you can see, pretty accurate. So what can you do with amplitude? Well, as I said, you can increase and decrease this one also over time to create some more interesting shapes. Maybe like tornadoes, where you start small and grow up bigger. For example, you just need to calculate this one in, or basically recalculate the amplitude over time. There are a lot of ways to do that, I believe, but I leave you guys to create your own stuff. So let's test everything out for now. Don't forget to save. I believe I didn't. And now let's play around with that. We have currently set up one circle with an amplitude of 0.5. If I decrease the amplitude to 0.2, you can see it will be smaller right now. And yeah, there we go. So a higher amplitude is basically a smaller radius. But also, if I increase the lifetime but from 5 to 10, it will increase the radius once again, no matter how small or big the amplitude is, or basically it's calculated in. So make sure that you don't confuse yourself with your circles. Also, lifetime will decrease, I believe. Let's change this one to 2, and will decrease or increase the speed of the particles itself when they are rotating in there. So a smaller lifetime, let's say 1, will at first you can see will be a smaller circle too. So there are a lot of options you have to increase and decrease speed and the radius and all the other things. Okay. So last but not least is going to be the frequency, when we are going to change this one to 3 and a z value to be 1. Or maybe, yeah, let's start with 1. What we will create is 3 frequencies with a speed of 1 in the z-axis, or to the top basically. And you can see there's going to be created a small helix. If it's not seen good enough, you might want to increase the rate of the particles, so you might can see this one better. If it's still hard for you to see and notice, you can also go over and change the shader of the particle system's material. But now you can see you can create a helix. Even if you go over and decrease the start size to 0.2, you should be able to see this one maybe a bit better. So now you can see how that is going to work. I don't know why it's wobbling so much. Let me just go over and increase that to 500. Maybe there's some issue. I don't know. But for the basics, it's going to be pretty much okay, I believe. So what you have right now is a helix you can create with that, a circle you can create with that, and instead of using the Z value, we just plant it in here just for testing. You can also go in and use the speed value. So if you change the start speed not to 0, which we have done in the script in here, but we might want to change this one to 1. Gonna save that script, and since it's private it doesn't matter. You should see even then it is able to do a helix with that speed value instead of using the Z value. So yeah, that is all I wanted to show you about circles and helixes and whatever you can create. Again, go over and change the amplitude to create some, I don't know, tornado stuff and all the other things you might have. And you can also go over and create whirlwinds, or galaxies, or the basics of galaxies. The problem is with a galaxy is you need to calculate them a bit different to just that one. But the base of that is going to be this. So yeah, try that one out. If you have any questions about that, feel free to ask me in the comments below. Don't forget to subscribe to my channel if you haven't already to see more videos in the future. And of course, make sure that you sum this video up if you like that. Also, if you want to read about everything, I have just a written article on my website www.xOctoMangames.com. I'm gonna blend this one in or type this in the description below. So make sure that you check this one out if you need any help and so on. So yeah, see you in the next tutorial. Bye bye.